Okay, and I hope we'll get a few more participants coming in, but thanks everybody for being here. I think we have 4 or 5 presenters today. I should have pulled up the list before. I was just chatting with Fritz and not paying attention. But just a little reminder, when you ask a question, please put it in the chat. And then for the presenters, if you can read the question out loud before answering it, then it will get captured in the recording. So, let me figure out here. So we have Frank going first. So Frank, whenever you want to start sharing, you can go ahead and get started.
All right. Well, hello, everyone. I assume you can hear me?
We can.
All right. And hopefully I can share this correctly.
I'll let you know when we can see it.
Okay.
I can see it coming up. There we go. That looks
All
good.
right. All right. Very good. Well, hello, everyone. My name is Frank Pereira, and my presentation is a temporal and spatial analysis of traffic accidents in Carroll County, Maryland. And this will be the period spanning before, during, and after the COVID pandemic. Let's see. There we go. Just to start out a little bit about me, I'm a senior branch forecaster for the National Weather Service's Weather Prediction Center in College Park, Maryland. I've worked with the National Weather Service for over 25 years. My main specialties are heavy precipitation and winter weather forecasting. I'm also the extreme temperature program lead and the GIS team lead. Now, you would expect this presentation to be about weather, but it's actually not. It's more about something that impacts my commute on a daily basis. I'm a commuter by car, and I'm in the car approximately an hour to work each way. So a little bit about the overview of the project. My objectives were to analyze the temporal and spatial accident trends in Carroll County, Maryland, from 2019 to 2023. I was exploring how the COVID pandemic affected traffic accidents patterns, and then hopefully provide actionable insights for policymakers to improve safety. So why does this matter? Again, it's a public safety issue. For the period I studied, there were 9,500 crashes in that 5-year period. 25% caused injuries or more. And again, I was hopeful that this would inform resource allocation and policy interventions to prevent future accidents. A little bit about Carroll County. It's a relatively small county, population of around 173,000, according to the 2020 census. It's a historically rural community that has recently become an exurb for the Baltimore and Washington metro areas. Approximately 35% of the county's commuters travel more than 45 minutes to work. That was a pre-pandemic stat, and like I mentioned, that includes me. Most of the major roads are open access state highways, and they're 2-lane roads. There are some exceptions through the primary commercial corridor through the county seat, which is Westminster, and a small segment, of Interstate 70 that runs through the southwestern corner of the county. A little bit about the previous research. A lot of studies have been, similar studies have been done looking at accidents. Kernel density estimation is a widely used method for identifying accident hotspots. Global Moran's I and Lisa reveal spatial clustering of accidents. A lot of the same things that we looked at in GEOG 586. While some use traditional approaches to investigate spatial autocorrelation, others use techniques more adapted to road networks, using road segments as spatial units and defining the relationships of those based on connectivity or proximity. Now, there were a few research gaps. I only found one study in Maryland at all, and that was focused on Baltimore City. And I didn't see many that focused on the pandemic before and after impacts. So the gaps I hope to address in this presentation were to focus again on Carroll County, obviously, and to integrate the pandemic era travel behavior into the analysis. The data sources I have Maryland crash data. This was collected by the Maryland State Police. This ran from 2019 to 2023. The attributes for this included approximate location, time, severity, road conditions, some anonymized driver information, and other things. The additional data sets I used, road center lines, both across Maryland and specific to Carroll County. And traffic data, this would be average daily traffic volume, mostly along primary routes. And this was used to provide spatial context and input into the spatial methods that I'm going to be describing. So in terms of the methodology, there was some cleanup to do. There was obviously some accidents that were attributed to Carroll County that did not occur in Carroll County, and there were also some accident points that were well removed from the road center lines. So I snapped a lot of those to the road center lines to account for the GPS inaccuracies that were um, in the data sets. And after that, I started my temporal analysis by plotting frequency by year, day, and time. And then I conducted a two-way analysis to assess the statistical significance of the patterns that I found. After that, I moved on to accident rates, normalizing the accident rates using the average annual daily traffic volume that I spoke of, as well as road length to calculate a accident rate that was per million vehicle miles traveled. I also needed to address missing AADTs. Unfortunately, uh, the state only collects mostly along primary roads. So a lot of the rural roads were well removed from where I had accurate counts. So I did do some linear interpolation for some of the nearby roads, but for more of the rural roads offset from where I had any data, unfortunately, I had to not take those into account for my analysis. Um, in terms of spatial analysis itself, descriptive statistics, a lot of, again, what we saw in 586, calculated the mean, median center, and spatial dispersion. I also did the KDE, highlighting accident spots. And I did weight those according to severity. State police do rate accidents according to their severity. Fatal, injury, and property damage are the three main categories that they use. In terms of spatial autocorrelation accidents rates, I did calculate the Moran's eye and local indicators of spatial analysis for clustering. And again, instead of using spatial adjacency or shared borders, I focused on road segments using k-nearest border or neighbor for road network context. The tools I used for data prep was mainly ArcGIS Pro, but after that, it was mostly R. So in terms of the results, the temporal trends, not too shocking here. There was a significant drop in accidents in 2020. This is a lot of when the stay-at-home orders were enacted, schools closed down, or switched over to remote learning. A lot of businesses shut down as well temporarily. And then after that, there was a partial rebound from 2021 through the 2023. Interestingly, fatal accidents did rise a little, as you can see on the chart on the right. They were fortunately, they were a very small percentage of the overall total accidents, but there was a slight increase. Otherwise, what I saw was typical of any other period. Higher weekday accidents, especially during the rush hour periods. All days saw declines, followed by some post-pandemic rebounds after that. Rush hour was typically the most accident prone. And you can see that here on the right. I created an accident density by day and week and hour. And the brighter colors are where more accidents were recorded during that time period. And if you can't see it too clearly, it generally follows the typical trend where you see a peak during the morning rush, perhaps a slight drop off, but then a real increase then during the afternoon hours when most folks are returning from work. In terms of the ANOVA findings, statistically significant differences in accident counts across the years. Like I mentioned, accidents did drop off significantly, especially from 2019 to 2020, and a significant variation by weekday. Weekday during the week, Monday through Friday, saw more accidents than the weekends. And again, frequency varied significantly by time and by time and day. There were fewer accidents on the weekend during what it would be the rush hours if they were during the weekday. But no significant variation between year and weekday, and no significant variation in hourly patterns by year. So in other words, the patterns pretty much remain the same, even though the overall numbers dropped off. They pretty much follow the same pattern from day to day and hour to hour throughout throughout the study period. In terms of spatial statistics, like I mentioned, I calculated the mean center, the median center, the central point, and the standard distance. And this is a composite of all 5 years on the right. And it was pretty much consistent for each individual year. Westminster, which is here in the center of the county, you can kind of see where it's kind of the nexus of all these primary roads that are coming together in the middle of the county. It was consistently identified as the center for accidents across all years. And again, this kind of reflects its role as the main or the primary commercial, one of the primary commercial centers. And like I mentioned, the transportation nexus for a lot of those roads coming together. Um, like I mentioned, there wasn't a whole lot of difference from year to year, but there were some subtle changes in the mean and median centers, suggesting a slight spatial shift in accident concentrations during the pandemic, but nothing that stood out too starkly. In terms of the KD hotspot analysis, um, here on the top left, this was 2019, kind of using this as a baseline for this. You can see Westminster there in the center part of the country really kind of stands out as a high density hotspot. Again, all major roads, a lot of the primary roads coming together in the county there. But you can also see some bright spots further to the south and east. A lot of those are a lot of the major corridors. Like I mentioned, a lot of folks traveling back and forth from Carroll County to Baltimore and Washington. So you can see some bright spots there along those major corridors, as well as some of the primary population centers in that area. Um, in terms of year-to-year changes, the accident density did decrease in and around Westminster, but there were some subtle increases in rural areas, perhaps potentially due to shifts in the travel patterns. And then post-pandemic, there was a partial rebound um, in and around Westminster, and then some new hotspots emerged along primary roads north and east, indicating perhaps evolving traffic patterns. But overall, the density in and around Westminster, you can see the 29 to 2023 difference. Density did decrease if you consider the whole period across Westminster. But again, like I mentioned, you can see some red spots or higher density differences that occurred through the pandemic. Next, turning to traffic volume. Again, I wanted to provide some context for accident trends by revealing patterns in road usage. And I use this for normalizing accident rates to account for variations in exposure. So as you can see, pre-pandemic, again, using 2019 as a baseline, 2019, the higher the red values, you can see these are the most heavily traveled corridors. Like I mentioned, the county itself only has about 173 people. So some of these red or more heavily traveled roads are carrying up to close to 75,000 cars in a single day. In terms of how the pandemic impacted, no surprise, there were significant decreases. And you can see here in the bottom right, the percentage change from year to year and then across the entire period. Now, I should mention, I didn't have 2023 values, so these only go through 2022. But you can see here in the top left, a significant decrease or a decrease in across many roads or almost all roads from 2019 to 2020, and then things started to rebound. And then after that, there was some various trends after that. But overall, if you look at the 2022 to 2019 differences, a lot of roads traffic did come down as some folks, continued to telecommute, work from home, and so forth. Um, Again, this matches up with what we saw, a lot of heavily traveled roads aligned with the higher densities accidents we saw in the KD analysis, and roads with lower traffic values, like I mentioned, saw inconsistent changes in accident patterns. But again, overall numbers were generally down in terms of traffic volume. In terms of accident rates, why did I do this? Raw accidents obviously do not account for variations in traffic volumes. And again, I wanted to provide a normalized measure to truly identify the hazardous road segments. Rates across the county, again, using 2019 as a baseline, were generally lower, but the brighter the orange, red values are the areas where they were relatively higher. Again, Westminster shows up as one of the areas of interest. But accidents after that, interestingly, the trends were all kind of all over the place. There were decreases in some areas, reflecting lower traffic volumes due to traffic restrictions. But there are also increases in other areas, suggesting while there was reduction in traffic volumes, the accidents did not decrease uniformly with them. So, like I mentioned, the inconsistent year-to-year patterns. Didn't find very many roads that saw sustained multi-year trends. There were a couple that saw sustained increases, and those were mostly in more rural parts of the country. Perhaps fewer cars on the road allowed people to travel a little bit faster through, or if they felt they could travel a little bit faster through that area. Um, but in terms of the spatial autocorrelation analysis, again, I wanted to see whether the accident rates were clustered, dispersed, or randomly distributed across the county area. I looked at Global Moran's Eye and Lisa plots. For the global Morans, the values were close to zero for all years, indicating no significant clustering, at least at the global scale.
Perfect.
Uh, um, in terms of the Lisa results, most segments were non-significant, kind of backing up what I saw in the Morans. There were a few localized clusters. I had to lower it to the 90% confidence.
I'll put it in percents.
Um, 90% confidence level. The few that I did find were not surprisingly in Westminster, including Engler Road, which I have highlighted here on the right. This is well known to be a popular route and intersection. A couple of very popular shopping centers on either side of it with entrances and exits. So you got cars making left turns out of both sides, and you can see it's actually multi-lane here. So it's kind of a complex road section of the roadway, and it's kind of known around town for being one of the more dangerous, relatively speaking, in terms of accident rates. So wrapping up whoops, sorry about that. My conclusions, oops, let me go back. Sorry, I advanced too far there. My conclusions are my big takeaways for this. Total accidents during 2020, again, reduced traffic volumes due to the pandemic, but again, recovering thereafter. Like I mentioned, accident patterns remain consistent through the pandemic in terms of timing, with weekday rush hour peaks persisting. KD analysis identified high-density hotspots in urbanized areas like Westminster, uh, influenced by traffic volume and complex road networks, probably. In terms of traffic volume and accident rates, traffic volume reductions, again, during the pandemic, correlated with the lower accident densities, particularly in the more urbanized areas around Westminster. In terms of the spatial correlation findings, again, Global Moran's Eye indicated a random distribution of accident rates across the country, suggesting a lack of systemic spatial clustering. The local LISA results identified some high-risk clusters, particularly within Westminster, and this may emphasize the need for targeted interventions in that area. In terms of policy and safety recommendations, if I were to have any that were to come out of this, focus strategies for urban hotspots, improved road design and enforcement, and upgrade for rural areas. Interventions should target weekday rush hours. Like I mentioned, that was a problem time period throughout the study. Persistent high accident rates on specific roads may highlight the need for tailored interventions, such as road improvements or speed enforcement for those roads. Some things that I did not get to address and would like to have, if I had more time, being a meteorologist, I would have liked to have incorporated additional factors like weather. I could have looked at things like road geometry and enforcement activities to perhaps refine the risk assessments for those roads and expand the methodology to other rural areas for comparative insights into accident dynamics and policy solutions. And I think that's all I have. And with that, I can stop sharing.
Good job, Frank.
Thank you.
And so we can have some questions. If you do want to unmute and ask your question, that's okay, or just go ahead and type into the chat. Looks like Fritz already has a question for you.
Yeah, Fritz, like I meant, that was one of the things I probably should have added that to the last bullet. Was one of the things that I didn't get to consider. I probably could I could have taken a little bit closer to look into, yeah, which roads, which, yeah, both state and highway, or both state and U.S. Taking a little bit closer look as to, interstate, that one little interstate that I mentioned segment is, but unfortunately, I didn't really get to take too close of a look at that. Um, Adrian, no, I don't. I actually kind of went into this not knowing what to expect. I was kind of underwhelmed a little bit by the spatial autocorrelation, but that may just been the nature of the data I was looking at and the fact that I couldn't look at everything across the county in terms of daily traffic volumes and such. But yeah,
And there's something from Marcella.
yes, the severity did play a role, and I did incorporate that a little bit into my I did incorporate that into my KDEs. I gave higher weighting. It was a 3-2-1 scale where fatal crashes got a higher weighting than injury crashes, and then property crashes got the lowest rating. Um, so
Okay. And did you address Marcella's? I might not have been paying attention. I was actually, maybe you did Marcella's right after.
yeah, she asked about how oh, I'm sorry, maybe not. No, I didn't. Temporal now Temporal analysis would look similar if the study was conducted at a different temporal resolution, say months or quarters instead of years. Yeah, that was one thing I considered because I know 2020 during 2020 it wasn't the same throughout the entire year. I know that a lot of the stay-at-home orders, went into effect early in the year, and then things started to relax after that. So it would have been, yeah, that would have been another way to start to slice the data to perhaps get a better idea of how the pandemic especially impacted that time period. Um, yeah.
Just one thing to add, I had read an article recently that it does sound like you had a lot of wrinkles to kind of work through because I read that the commutes are, or the rush hour is a little different because some people might work hybrid, for remote from home in the morning or leave earlier in the day. So kind of spread out when the actual rush hour was. So yeah, it sounds like you had a lot to untangle, but really interesting.
Yeah, in terms of the hours itself, I did group those when doing some of my temporal analysis because, yeah, I grouped it into morning, um, afternoon, evening, and then overnight to kind of help with that part of the analysis. That was the time facet that I did do some grouping with, and to kind of get a better idea of, or a different look at how the trends evolved.
Yeah. Great job. Well, if you want
Thank
to, yeah, if you could put your email address in the chat, just in case anybody else has some questions for you that they're still thinking about.
Okay.
And we will move on. Next up is Elizabeth Week. So Elizabeth, whenever you're ready, you can go ahead and start.
Okay, great. I will go ahead and start bringing up the slides.
And we can hear you great, and I'll let you know when we can see them.
Perfect.
Yep, we can see it. So I guess once you're in presentation mode, you can go ahead and start.
Okay. Mine. Whoa. Sorry, I had my practice going. Let's see, make sure that got deleted off of there. Since it's such a large topic as Marcel is tracking, trying to scope it down, did a few practice run-throughs for time. Make sure they're all gone. Sorry, I thought I got them all. Okay, so let's take 2 on that. I apologize.
No problem.
Okay, so I'm Elizabeth Weeks, and I am going to be going over military ontology implementation in a relational database management system. So kind of a newer area, so I wanted to take a step back and kind of explain the situation that we were facing here with kind of my own day job as a government employee in the intelligence community, supporting the Department of Defense. So on the screen, you have a bunch of logos across the intelligence community, the IC, and the Department of Defense. What we struggle with as a community, so when I say community throughout the brief, I'm referring to both the IC and DoD. On the intelligence perspective, we have a lot of data sources, but we're all sometimes looking at the same type of entity or object or asking similar questions that we have to pull from all these different bins across the enterprise. So each of these logos, for example, National Geospatial Intelligence Agency, NGA, is the functional manager for GEOINT, right? And then we have the National Security Agency, NSA, they're the functional manager for signals intelligence. Different pockets of data, but they're also looking at the same target set, again, going back to target, objects, and entity, all kind of focusing on the same thing. So the current state, if we ask our analysts a request for information or to look at a particular object that might be causing a threat to the United States, they have to go through all these different databases, different logins, different role-based accesses. Sometimes the information across NSA or NGA might be conflicting for various different reasons, whether it's, more historical, maybe it was a different time of collection or different level of precision for that particular object. Ultimately, trying to answer that request for information, that RFI. So this process is a little time intensive, and again, sometimes the analyst just has so many databases to go through, they're not quite sure which one they should start with or which one is the authoritative place to go for your answer. So that was the proposed solution, looking to use a relational database management system with the implementation of an ontology. Ultimately, we're really focused on an authoritative database and how to create that with the implementation of an ontology, right? How do we create a unified model focused on individual objects? So with that, really this project focused on exploring methodologies for that ontology implementation. How does ontology improve battle space awareness for a commander or decision maker? So with that, we're thinking, how do we increase time and confidence in answering those RFIs with your data? And ultimately to create a framework that, if proven that the ontology can improve battle space awareness, how do we create a structure to continue to evolve the ontology base itself? So again, just highlighting the problem set is multiple data sets, and then we have different accesses, different ability to access the data, and then ultimately, how does that analyst juggle across the enterprise at large with such a large amount of data? So again, we touched on the objectives and goals that we're going to be focusing on, which really is the ontology itself. And ontology is a large discipline. So if anyone has interest in it, it can definitely go on different tangents, but for the scope of this, we won't go too far into what ontology is itself, but the study of an existence and how an object is related to other attributes and other objects itself within a particular domain. Previous research on ontology has been focused primarily on the medical community. So you can think about how different diseases are related to each other, what are symptoms, how do you correlate all this data and different information to give a particular patient not only a diagnosis, but how is it related to prescription medication for treatment. So they've moved themselves to an object-based production to, again, how do you manage large quantities of data and heterogeneous databases? So this is the first time that military organizations, in conjunction with the intelligence community, has really looked into using ontology to create that unified model. The methodology really focused on a particular working group to help kick this off. I hosted this 8 and 9 October at NGA. We had the director of the Defense Intelligence Activity, our agency rather, DIA, come and give his strategic guidance. But we'll go through kind of the steps, really starting with 3 different groups that were at this working group. And that focused again on those senior leaders providing their overall objectives. What do they want to know from battle space awareness? Those who collect and analyze the data. So they were key members of this working group, as well as the end users. So those who are actually using the data to write the reports, the ones that are visually inspecting the models that we're presenting from the start of implementing the ontology itself. So at the working group, we really focused, okay, we know we have this problem of data. We have a lot of data. It's everywhere. It's not standard. Okay, but what do we want to do with it? So let's focus on the end state. What is that competency question that we had for the visualization? So going back to, again, what is those questions your decision makers would want to see modeled from the data sets? So for the project, to help keep it scoped, we just focused on answering questions about naval vessels. In particular, one of the competency questions that we had from the working group was, how does the sea state impact operational readiness of that particular naval vessel? So starting from there in that particular competency question, we had to start defining the class, which is naval vessel, and what are the attributes? Again, those things that help define everything that we know about that naval vessel, and to help answer that competency question of how does sea state impact the functional readiness of that vessel. So now that we have our competency question, we have our class, which is that naval vessel, and the attributes, we need to start building out that model, right? So things that we wanted to know: has location, okay, how is that related? What about the home port, where it came from? The heading, the direction, what is the length of the vessel? So start mapping out. This is just a very rudimentary example, but walking through all the naval vessels we wanted, all the attributes, again, that would help answer our initial competency question. Once we have the attributes known, we need to start mapping it to what we dubbed as the authoritative data source. So I'll touch on the data sources here in a minute. But again, the mapping was critical, especially when we talk about our databases across the enterprise might have multiple databases you can get the location from, but which one is the most accurate, or the one that would take precedence if multiple data sources would answer that single attribute? So this is where we dug across the model, was that building up a playbook, right? So all the information we would want to know about that object and the attributes and the sources that came from. So the data itself for this project, I came across both NGA. We focused on imagery, which typically came in the format of various rasters. In signals intelligence, again, focused on comment. Communication intelligence, which is mainly focused, you can think on radio frequencies, external information of that signal, which gives you items such as location of that naval vessel, as well as we focused on electronic intelligence. So that comes from radar systems. Most of that information was in what we call a signal binary format. So again, you think of these two heterogeneous data sets across NSA, NGA, and how implementing ontology was able to bring them together in a relational database. The data itself, I do want to highlight one of the struggles we face as a community, which was interesting to help recommend changing some of our policies. So these functional managers across NSA and NGA were able to come together. There are executive orders such as 13,526 and ICD 203 and 503 that we had to remain compliant. So these very sensitive sources were able to come together in a holistic database. The next part was actually scripting the code. So it's taking that model we just made and then now creating a knowledge graph that would be implemented into the system itself. This was using the OWL, which is basically a Python script, utilizing a program called Protege. That has kind of been the base for the tool set that most ontologists have been known to use. You're able to kind of build your own scripts, point to the database that you want the information to come from, explain to the machine, because it is machine readable, where that information comes from and how it's related to the larger object. The implementation itself, it came from a rudimentary flow. When you start looking at the databases on the left of the screen where you kind of see one, that's where we had to start cleaning the data, if you will. So we wanted to fix some of the taxonomy, right? For some of the imagery on the raster, the locations were lat longs versus MGRS grids. So how do you build these different data sources to come together in a normalization practice? Because we cannot standardize the way that our overhead constellation actually outputs the data, right? We can't fix our historical satellites to now say, hey, we want you to fit this standard. So we had to normalize the data itself. So that was part of the process and took a little bit longer than we wanted. The data would now go forward from the individual sensors into the databases. The way we tagged it is really where we started to implement the ontology itself. So it was together unified with a common ID with the subsequent attributes following underneath each of the particular UUIDs, that unique identifier, which led to our new authoritative database that you see in the figure that's listed as 3 on the slide. So all the information you could think, this is just inside from NGA. The same process leading to that pipeline there for 3 was where the information for NSA came through as well. Then it was fused with near real-time collection. So some of the information was content driven. That's what we've talked to up until now. And then the fusion at number 4 is where we had that near real-time signals intelligence coming in, connecting again, utilizing the ontology's UUID with near real-time collection of where is that object in near real-time in space. The filtering based on what you wanted, your confidence of how sure you were that that was the actual location of the actual object was kind of the last piece of it before you ended with your user interface, which is number 6 on the screen. Quite a bit of testing and evaluation. A lot of the testing came based on measures of effectiveness. How well did we meet some of our objectives that we established ahead of time? And then how well did they perform, our measures of performance. So a lot of discussions with the analysts who are visualizing the information, then going back through the databases to see if there was any issues with our data flow at large, having focus groups for then documentation of how can we do better. Was our data sources the right data sources? Was it authoritative? How do we prevent what we call circular reporting? Again, so you don't have 2 data sources trying to conflict information under one object. The results overall for having such slim databases, our accuracy was fairly well, mixing those content-driven informations for the object with the near real-time satellite overhead signals intelligence. Interoperability, we saw great success across 3 different databases within NGA coming together to create one, similar to what we did on the NSA side. So we saw that ontology was able to enhance fusion, vice what we were doing before was post-dissemination correlation. And because that interoperability, being able to fuse our data set further left of our visualization, we were able to save a lot of time for our analysts, again, speeding up the decision cycle for a lot of our leaders and our commanders that need to act on these wide disparate data sets. The query performance, although limited for the visualization that we had for this, works really well. The reasoning, again, what was authoritative for our attributes. Since it was hard-coded, it seemed to produce without many issues what attribute was related to that particular object. For the visibility, again, the objects were able to populate onto the visualization, which we were using a National Reconnaissance Office NRO tool suite, but ArcGIS was actually the geographic map in the background. Based on what we saw using these databases across NSA and NGA, we do see that it is able to scale, which is really exciting based on we wanted to use this as a framework going forward. So this model will carry on past these databases. So how do we include others throughout the intelligence community and the Department of Defense? Again, ultimately saving the time for increased battle space awareness. So in conclusion, we looked forward to continue to build out how ontology implementation can better the IC and Department of Defense. So here on Wednesday, I'm actually running a 60-minute demonstration of how we are using this data model to ultimately answer some of those competency questions that we came up with during that working group. For example, just to highlight it, is understanding all the attributes of the naval vessel. We are now able to do more predictive modeling, which was another success coming out of it, of understanding, going back to the attributes, where that naval vessel came from, based on the speed it's going, the current location, and again, the attribute of how much fuel we know that they can carry. We're now able to predict out where they're going, right? So that's a new feature to understand as a commander. If you have a threat and you see all these naval vessels in your area of operations, you can start modeling out places that you know they could particularly go during their path or where they might need to retrograde back to their home port. So again, very exciting to see the modeling aspect of the implementation of the ontology. So we look forward to showcasing that on Thursday to the joint staff, both at the Pentagon and across the intel community. So I'll pause there for any questions. I know that's kind of a lot, but we were really excited with seeing some of the results initially.
Great. Nice job, Elizabeth.
Thank you.
Looks like we have, Fritz has a question already.
Okay. He said, interesting presentation. I realize the presentation is a big picture of your study. However, I was curious about the details of the relationship model. It seems like many of the attributes were depicting real-time elements of the vessel. Would the assets or capabilities of the vessel also be relevant as an attribute in the model? This idea would likely be more for mission planning, I suppose. Yeah, so that was a big difference where we talk about content from an all source perspective, and some of that can be historical, where I mentioned at the end, fuel tank level, right, versus that real-time information mainly focused on the current location. So it is a mix of both. So I just gave you a small subset, our playbook for our naval vessel. I think we're up to about 183 different attributes that we have for that vessel. So that's what makes the ontology exciting, because how much that you can continue to develop on it. So once it's coded, it doesn't mean it's the end all be all, and you have to completely scrap it to update it. Fritz, does that answer your question before I go on to the next one? Yes, okay. The next question, this reminds me of the tug and pull of data between local government agencies. Does the working group foresee any challenges having the various organizations adopt this ontology? No, because it's going to be mandated by the power that be from the Secretary of Defense level that was put into writing. What we're struggling with now past this, yeah, it is helpful, right? I was very excited to get that in writing. What we struggle when you talk about the tug and pull is our authority to transmit, or ATOs, between our object management services, or OMSs. So the last 3 weeks, I was actually out at US Indo-PACOM headquarters in Hawaii. I know that we were there at the same time last year about for different things. But that was our discussion, is how to get those ATOs so we can include more data sets than just NSA and NGA. Given that there's 17 IC agencies and a lot more data sets across the Department of Defense that doesn't even fall into those 17 agencies.
Okay, great job. Okay, we will move on. I guess if you can, same thing, Elizabeth, if you could put your email address in the chat, people might have some questions to follow up with.
Absolutely, thank you.
Clapping there from a few folks. And next up is Norman Lee. So Norman, whenever you're ready, you can go ahead and start sharing. We could see it, and I think we can hear you. Once you talk, I'll let you know.
Okay.
Yeah, we can hear you.
Okay. So shall I begin?
Yes, go ahead.
Okay. Hello everyone. My name is Norman Lee, and my capstone project title is called GIS Analysis of Installing Charging Facility at Public Meter Parking Space in Hong Kong. And before I begin, I would like to introduce myself. I'm currently working as a project manager for an underground utility company in Hong Kong, and my role is to manage some underground utility inspection projects. So let's begin my project presentation. Global warming causes climate change around the world, and it causes problems such as increasing global temperature, rising sea level, and many severe storms, and species die because of this extreme weather. And the major cause of global warming is the carbon dioxide coming from the conventional fuel vehicles. With the advance in battery technologies and financial support from the Hong Kong government, and people are switching from the conventional fuel vehicle to electrical vehicle. And people also don't want to pay for the high fuel prices, and they usually drive a very short distance. There are a total of 105,000 electrical vehicles at the end of the October 2024. And it is expected that 53,000 electrical vehicle will be sold in Hong Kong by year 2039. And a report from CBRE that there's a severe shortage of electrical vehicle charging station in Hong Kong. And currently, there are only about 9,107 chargers are available for public charging. And these are not enough to support the high demand for public charger. But the good news is that there are around 19,000 public meter parking spaces, and charging facility can be installed in these public meter parking spaces to supplement the existing charging stations. And another concern is the location of the charging station are not evenly distributed. And when planning the location of the charging stations, people often consider the coverage of demand, convenience, investment, and operating costs. And this leads to a charging station often built in areas which has high income and highly educated people. And we would like to have some charging station to locate at a lower income group of people because of the electrical vehicle is more affordable in nowadays. This study aimed to explore the potential of installing charging facility at public meter parking spaces. It will first determine the location coverage of these public meter parking spaces, and then I will evaluate the equity in accessibility with respect to the monthly household income level. And this study is important for the city planner to plan ahead for the rapid expansion of electrical vehicle in the future. I've classified my literature review into three groups. The first group is that the use of different methods or approach to identify suitable location of charging station. And the second group is that the study try to investigate whether a particular type of site For example, shopping mall, residential parking space, petrol station, whether this type of site is suitable for electric vehicle charging stations. And the third group is that those studies try to correlate the location of the electric vehicle charging station to the equity in assets. Many researchers use different models to study the location of electrical vehicle charging station. For example, they use particle swarm optimization mathematical models, mixed integer linear programming models, multi-agent simulation model, analytical hierarchy process, grid partition method, genetic algorithm, and behavior model. And the type of site can be classified into two types of networks, continuous and discrete. Petrol station along the highway is an example of a continuous network. And Napoli studied the charging station in highways networks. Shopping mall, commercial building, car park are an example of a discrete network. And Vansula used commercial and industrial land zone to study in their study, and Charlie has used the lamppost for the charging station. Also, a previous study have considered cost, distance, time, destination, driving route, and when finding the location of the electric vehicle charging station. But there's not a lot of study on equitable access to public electric vehicle charger. He uses socio-demographic data on their research to support the purchasing demand of electric vehicle, and Penn has studied the inequity of charging facilities. There are also other research which consider equity as well. So this study focused on two things. First is to evaluate the 23-minute walking distance from the public meter parking spaces, and the second is to evaluate the equity in assets for these public meter parking spaces. So for the data set for this study used the Hong Kong 1980 grid coordinating system. The map on the left is the Hong Kong boundary, and the map on the right shows the 18 districts of Hong Kong, and each color represents a single district. And the first data set I used for this study is the location of the public meter parking spaces in Hong Kong. And there are a total about 20,000 meter parking spaces record. And each red color point represents a single public meter parking spaces in Hong Kong. The second data set is the building data set. There are a total of 341,000 building records. And the map on the right-hand side show the building in orange color. And the third data set is the monthly household income level data set. The map on the right-hand side shows two different groups of income level. The green color areas are the district that has a median monthly household income greater than Hong Kong dollars, like $45,000. And the white color areas are the district that has a mean monthly household income lower than or equal to $45,000. Two methodology were used for my study. To determine the 23-minute extent of coverage, I need to find out the building areas that are covered by these public meter parking spaces. So first, I will use the drive time analysis in AdjustPool to find the 20-minute walking time coverage rate from the public meter parking spaces. And the below flowchart shows the process of creating a map for calculating the building areas within 23 minutes from the public meter parking spaces. After the drive time analysis, I create a multiple polygon which I need to use the dissolve tools to merge together. And the the map on the left hand side is before the using the dissolving tools, and the map on the right hand side is after I use the dissolving. After dissolving. And this maps on the right-hand side shows the full map of the 23 public meter parking spaces coverage. And I have to use the clipping tools to keep the buildings that are inside the 23 meter coverage. And the left-hand map is before the clipping, and the right-hand map is after the clipping. And you can see that like some buildings are removed after the clipping, and this map is now ready for my analysis, and I will talk about it in my result session. And for the second part of my study on equity in assets, I used the McVitie U-test for this part. The McVitie U-test used to test whether there's a difference between two groups, and the data need not to be normally distributed. And to determine if there's a difference between two groups, the rank sum of two groups are calculated. To evaluate the equity of assets between the high and low income, I have divided the monthly household income into two groups. One group is the district that are greater than $45,000, and the rest of the district below belongs to the low income group. I count both the number of points with its 23-minute walking distance that intercept the high income areas, and the number of points with 23-minute walking distance that intercept the low income areas. And also, like now, this data are ready for the analysis. So for my result, as mentioned previously, I have created a map of 23-minute walking time coverage that look like the one on the right-hand side. The blue color buildings polygons are buildings within 23-minute walking distance, and red color buildings polygon are the buildings outside of the 23-minute walking distance. And the yellow color background are the 23-minute walking distance coverage. To find the percentage of coverage, I use this equation. From the maps, I get the total areas of all buildings, which is around 64 square kilometers. And the total polygon area for building that are within 23-minute walking distance is about 51 kilometers square. So when I use this equation, the percentage of coverage is around 80.76%. And this high percentage value shows that it is feasible to use public meter parking spaces for electric vehicles charging. And for the second part on equity in assets, I have to set up two hypotheses. The null hypothesis is that there's no difference between the equity in assets of the two income groups. And the alternative hypothesis is that there is a difference between the equity in assets of the two income groups. And these are the calculated values from the McVitie U-test. So after some calculation, it shows that the H-naught cannot be rejected since the p-value about 0.732 0.73 is greater than the alpha, which is 0.05. The alpha is the confidence level. The larger the p-value, the more it supports the hypothesis. So, and the set value is around 0.3414, is in the 95% region of acceptance. So the conclusion is that there's no difference between the accessibility in the public meter parking space for by the high income group and the low income group. So I cannot reject the hypothesis, which is high income group is equal to the low income group. There are few limitations to my study. First, the willingness to walk for 23 minutes is depend on the individual. Some people may only like to walk for 5 minutes, while others can walk for more than like half an hour. Second, the purchaser's intention to adopt an electrical vehicle can depend on many other factors. People who have high household income may not willing to own an electrical vehicle if they are living close to the public transport or living close to their workplace. And third, the cutoff income level for this study may affect by the inflation rate. Like this statistic is come from like year 2021. So over the years, the salary made for the individual may increase quite a lot because of the inflation rate. And finally, this study did not separate the residential building from the non-residential building. So for future study, like people can consider different working time or different equity parameters. And this study can be applied to other similar city as well. And this study gives the urban planner or policymaker an idea of a possible location of installing electric vehicle charging station. So in conclusion, installing electric vehicle charger to the public meter parking spaces is a possible way to relieve the insufficient electric vehicle charging station problem. So here are some of my lessons. So thank you. So any questions?
Great job, Norman. Wait to see if some questions come in. Do you see the one from Fritz there?
I don't see any
Oh, I think he might have written it. Okay, hold on. It's Fritz, do you want to paste that again? It didn't go to everybody. I'll read it as well until he puts it in there. It says, nice presentation. Have you thought about how you would make your recommendations to the Hong Kong municipality officials to enact your findings?
like maybe I can talk to the people from uh I can talk to the people like from the government and like maybe in some seminar or other like other event I can like discuss the result with them so they may find it useful. So I see the charging station here. I wonder if any is possible to add the technology. Oh, they could be.
And my question isn't part of your research. So if you have not come across that, it's fine to not know the answer to it. I was just kind of curious.
Okay. Like I think I in my research I did not like go through like the technology whether it's like will be out of date quickly. And I think like in Hong Kong like the technology is still like not in Hong Kong. Like in Hong Kong they are still adapting the electric vehicle. Like I think it won't be out of date so fast. Like
Great, thanks.
and yeah, I was wondering if 20 people working come from each other or not. It seems like yeah, for the 23-minute walking distance, the reason that I choose 23-minute walking distance is like I saw some other research. Like they said that like 23 minutes is an like is the acceptable like walking distance for the people like from around the world. So that's why I choose like 23-minute walking distance.
Okay, great. Norman, if you want to put your email address into the chat, that'd be great. We might have some other people who want to email you some additional questions.
Sure. Thank
And
you.
yeah, and next up we have Brianna Bradshaw. So Brianna, whenever you're ready, you can go ahead. Brianna, are you in here and ready to share? I see you on the list, so I know you're in here, but no, we're just a little bit behind schedule, but not much. So, okay, here, Brianna's writing to me. Okay. Brianna, try leaving and coming back in. Sometimes that will solve audio problems. We'll be patient. Just close up your Zoom and then come back in, and we will hope that that solves it. And Jen, I see you here, so I guess it's possible that you might need to go before Brianna. We'll see.
Yeah, my meeting ended a little early. If she can't get connected, I can jump in.
Well, that is great to know. Thank you. For another minute here, and I don't want to tell you to start and then have her come back in and it works. And so, and she's probably thinking, why don't I have that bookmarked? She's probably trying to find the link right now. There we go. Hey, any luck, Brianna? I don't hear you yet. Okay, since we don't hear you yet, Brianna, it sounds like you're still having trouble. I'm gonna have Jen go ahead, and then maybe you can troubleshoot on your own here, and we'll hope for the best, and then you can go after Jen. So I'm just gonna assume that's okay with you, and Jen, you can go ahead and start sharing when you're ready.
Okay, thank you very much. Can you all hear me okay?
Yes.
All right, I will share my presentation and go into presenter mode. Okay, presenter mode. There we go. All right, look okay to everybody?
Looks great.
Awesome, thank you. So thank you for having me here today. My talk is called Agricultural Suitability Analysis, or Expanding the Fields of a Small Family Farm. So I'm going to talk to you about that today. First, a little about me. No, this isn't a self-portrait, but I just like that picture of this lady. I am a 30-year, I like to say, survivor of IT and IT industry. I was formerly responsible for an enterprise Esri platform, which is how I got started in this degree a long time ago. Currently, I am an Agile coach and GIS enthusiast. And of course, I'm a friend of a farm owner, which is how this topic came about. So what I'm going to do today is I'll give you a brief introduction, talk about the project goals and objectives, talk about the previous research, the data and methodology that I followed, the results and discussion, and we'll give you some conclusions. So jumping right into the introduction, the worldwide population is growing. 50 billion people by 2050 is the current estimate. And we need more people. When we have more people, we need more food. And one way to get more food is to find arable land and have more farms. Food comes from farms. There have been a lot of studies that have analyzed land for agricultural suitability. They have been at the regional level. And one of the methods that is commonly used is the analytical hierarchy process, or AHP, which I'll talk about. It's often used in these large areas, but can it apply to an individual farm? So the goals and objectives for the project: how can, if it can at all, the AHP help the individual farmer identify arable land on their property? So the goals here are to test the AHP on an individual farm, see if fields can be identified for the crops that they grow now, corn, soybeans, and wheat, or what they currently grow, verify that this concept is applicable to the local farmer, and then potentially be able to use this to find more arable land at the individual farm level. So in the previous research, what I found is that, in 1976, the FAO, which is the Food and Agriculture Organization of the United Nations, they developed this framework for evaluating land, and it also classifies the land into different levels of suitability for agriculture. Over time, since then, more frameworks and models have evolved to get more advanced, use new tools as they were developed. And all modern models use multiple criteria. They're called multiple criteria decision making, or MCDM. And one of these methods that uses multiple criteria is the analytical hierarchy process. It combines with GIS, and it is used very often to evaluate agricultural suitability. So a lot of the studies use the AHP with GIS to determine agricultural suitability. But they've been done on these large regions, entire countries, entire state of Ohio. This is what the research is looking at. It's looking at these very, very large areas. So they also have said there have been people who studied different models. So if I use the AHP or if I use a different model, let me compare those two. And what they found is they produce similar results. And so if the different models produce similar results, using AHP would be appropriate for this study. And what it does is it applies weights to different factors to determine suitability. And later on, we'll explain what the factors are that I used. And then you basically stack these criteria and their weights using the GIS to determine ultimately the agricultural suitability for your farm, for your land. So again, these studies, they've applied these really, really large areas, but they haven't studied individual farm level. They've been very, very, like, as I said, the entire state of Ohio was studied. That doesn't necessarily help an individual farmer decide if there's more arable land on his property. So an individual farmer, as the one I used in this study, could really learn, hey, do I have more opportunities to expand my fields? I can improve my yield and make more food for this growing population. So this study aimed to determine, can I use AHP on the individual farm? The data and methodology I used, there was several broad categories of data that you need to do this type of study. So you need to know your area of interest, your study area boundary. You need to know what the crops need. So each crop has a different requirement for its soil, for its weather, for its water, for its slope. It all has these needs. What are the soil characteristics in the particular area of interest? What are the topographic characteristics in the area of interest? And are there any places where we can't actually use for farming? There are restrictions on that as well. And then, of course, when you're studying these large areas, you need to know what are the weather trends, because they're going to vary, especially for states or countries, are going to vary across that land. For this particular study, though, I was able to omit the weather trends from the study because within the farm, the weather is consistent. So I didn't have to use the weather. So it is not part of my data use. So you'll see here the list: the study area, soil characteristics, topographic characteristics, and there are a couple restricted areas as well. The study area itself is in Eastern Virginia, outside of Richmond in Hanover County. And to the left, you'll see the property boundary. It is this irregular area, is made up of 250 total acres. And right now, 23 of those acres are farmed out of 200. So it's less than 10% is farmed. If you can imagine, that's potentially a big opportunity. The crops that they grow there, as I've mentioned, include corn, soybeans, and wheat. They do them in rotation each year, and then they have a ground cover crop in the winter. There are, in order to, determine if the crops can grow, one of the things we need to know is the soil type. So the USDA maintains a very detailed soil database with a lot of different soils in it. There are 11 that cross the farm boundary. Some characteristics do match what crops need to grow and some don't. As you can see here in the table, there's different information like the different soil makeup. That's the actual texture of the soil, the pH, the classification, the land capability classification, the hydrologic soil group, that's how it maintains water. The land cap classification is, again, the USDA has gone through and said what's appropriate for crops, what's not appropriate for crops. So all of this information was used as an input. Also slope. Slope is very important. It's very hard to grow crops in a very steep slope. So the slope was derived from a DEM. There was a 1 meter DEM that was produced out of a LiDAR study done in 2015. And then the slope ranges as they're appropriate for growing crops were determined by the FAO. So that's part of their land capability classification. So I'll show you how those relate a little bit later, how the slope fits into the bigger picture. You can see in the image on the left, the property is not very even, right? There's a lot of ravines, there's a lot of steep slopes in there. So that did impact the outcome. We also have to know where the water is, right? So too little water, we can't grow crops, but too much water, we can't grow them either, especially for corn, rice, corn and soybeans and wheat. If we were growing rice, that would be a different thing. So what we want to know is where's the water, right? And there are rivers and streams, there's a water body, and there are flood zones based on those rivers and streams in the property boundary. So understanding where those are is important. Also, in Eastern Virginia, a lot of the water connects itself to the Chesapeake Bay. The Chesapeake Bay Preservation Act says protect the bay. So anything that fits into the network of water that flows into the bay falls under this Chesapeake Bay Resource Protection Area, or RPA. So here you can see that the property does have a significant portion of it that crosses this RPA, which means they're not suitable for farming. You cannot farm in the areas that cross the RPA. So the methodology I follow is divided into 3 sections. First, I set up the attributes, and I prepared the data, and then I processed it. So I'll go through each of these steps in more detail, but I determined the factor weightings for AHP. I determined the suitability rating levels, which I'll show you. Then I did some clipping and rasterizing of polygons, and I created a slope from the DEM, reclassified the rasters to these rating levels, and then executed the weighted overlay tool. This did the bulk of the work, and then I excluded some of the binary areas where you're not allowed to farm. So let's talk about AHP. So what it does is it basically compares, you pick out your factors and then you compare them in pairs, and it determines these relative weights. So for example, in the case of the 3 factors used in the study, soil type, slope, and flood zone, each one was compared in pairs, and I sent these to the experts. So the experts in this case I used were the farmers. They have generations worth of farming experience in the area and are currently farming this land, and said basically, if you have a soil type or slope, which is more important and like to what extent? And then slope to flood zone, soil type to flood zone. So you take these numbers and these comparison weightings rather, and actually put them into an Excel workbook specifically designed and programmed to calculate AHP weightings, which is very fortunate. And what we came out is the soil type is the least impactful of the factors. The flood zone is next, and the slope really has an impact on whether or not you can grow crops in an area. So these were the factors, these were the weightings for the factors that were applied in the study, as you see here. Next, each characteristic within each factor had to be given a numeric value, which is called a suitability rating level. So again, you see the FAO here they have two categories, suitable, not suitable, pretty straightforward. And then within that, they divide it into classes. So from highly suitable to permanently not suitable. In order to make the tool work, I needed to assign a numeric value to these so that the math could come out combined with the weighting. So the most suitable land is rated 5, the least suitable land is rated 1, and everything else gets a rating in between. So that each of the characteristics within the soil type, the slope, and the flood zone were applied a suitability class and the corresponding suitability rating level. So for example, earlier we talked about the slope, 0 to 8% slope in grade is suitability 1, highly suitable, it gets a 5. And from there we go down until we're 50 to 100% permanently not suitable for agriculture. And each characteristic, each soil type, and each flood zone were given these weightings. The DEM created the slope raster. Again, as you can see, as you probably infer from the hillshade, there's a lot of, significant slopes, and there are also some very level areas on the property. So this was generated from ArcGIS Pro, and you can see the slopes that were used in the final calculation. Then we had to rasterize the polygons and then reclassify them. So obviously polygons into raster, that was the tool used to make those, but then each cell was aligned with the DEM using the snap raster. And then each cell was given, using reclassify, each cell was given the corresponding SRL or suitability rating level. So at the end of the day, each layer, each factors layer, each cell had the suitability rating value assigned to it for that particular characteristic. The weighted overlay tool does the final work. This is the image that is in the help from Esri, but you can see if each brownish raster were one of my factors and the influence was the AHP rating in percent, when combined, it gives you the output that will determine, for my case, where is their agriculture suitability and what areas are not suitable for agriculture. So at the end, right, I didn't take into account I call them the binary areas. So the Chesapeake Bay RPA, the rivers and streams and the water bodies. You can't farm in there, right? So they're either farmable or not farmable. So what I did was I crossed them against the output of the weighted overlay tool and eliminated them. I gave them a suitability rating of 1 if they were in those areas, and everything else was maintained the output of the weighted overlay. And so that ended up giving me my final result. So here are the results. So this is the map. So you can see there are some opportunities for field expansion in dark green, and the existing fields, they are outlined in pink. Fortunately, they confirmed that they were in a suitable area. So those are the fields currently being farmed, and they have ended up in a suitable area for farming. You can see that the very slopey areas are kind of not suitable. And then, of course, the Chesapeake Bay RPA and the water areas are permanently not suitable. So there is area for expansion on this farm. And in the table, it shows you acres by suitability rating level, which is interesting in this number of acres that there's really not, a majority of acres are not necessarily suitable for farming. The first opportunity with these results might be to expand the existing fields. There's a large contiguous area of 64.8 acres that might be able to, that the entirety of the farmed field fits within, that might be an opportunity for farmers to just kind of increase their edges and add on up to 41.8 acres. So let's talk about this a little bit. So when you do apply AHP to individual farms, what you find is the resulting areas have jagged borders, and fields, as we know, have to have smooth borders because you have farming equipment and you don't want to go around, steep edges. So it might not end up being the whole entire expandability. These edges would have to be smooth. Also, this study didn't take into account the fact that you can terraform land, right? So you can change the slope if you need to. You can alter the soil chemistry, which is why the soil chemistry was rated the lowest, right? Because it can be altered. You can apply chemicals. So those things weren't taken into account. And so there might be opportunities for more farmable land, arable land in this farm. Also, there might be accessibility issues. If you saw before in this map, there's areas off to the northeast that I don't know how you get to. So they might not actually be an opportunity to farm there. So accessibility issues would have to be taken into account. So there would be some modifications to the process that I would do if I were to repeat this and make it a little bit more refined. Also automation, right? So I did these steps by hand, but fortunately I was able to create Python notebook to record the steps as I went through this. So automation will make this more easily repeatable if I were to add factors, and the AFP weightings, because they are variables, essentially can be altered before the rerun, as can the SRLs or suitability rating levels. And farms in this area share most of the characteristics. So changing the area of interest clip boundary would make this really reasonably quickly repeatable using on another farm if that was of interest to somebody. However, if I did go to another area or was looking at another crop, they'd have to do more research and data gathering, but the process itself would be repeatable. So in the end, success. I think this works for the small farm. The field expansion candidates were identified. The current fields fell right within the suitable areas, highly suitable for farming. The opportunities for improvement to the process, this methodology were identified, and crop yield can be increased to feed a growing population, which is good news for us. There are a long list of references, even more in the final paper, and you know, so many interesting things to read up on this. It is a very widely studied area, so they're mentioned here. Thank you again. I look forward to any questions, and you know, for reference as we talk through questions, you know, success. So I'll open it up to questions. What can I answer for you? Just reading through the chat here. Stakeholders, white rule. A tool, yes, I could, and that's what I was thinking is how do I make this available to farmers to be able to decide the inputs, and with very little, you know, necessary skills, could we figure out how to make it repeatable for any farmer that was interested in examining their farm? What would it take? The scripting itself is easy, but how finding those inputs, for example, the 1 meter DEM came from a 2015 LiDAR study. Not everybody has a 1 meter DEM at their fingertips, so that slope, you know, would be something to come up. The model says a patch of ground is suitable for farming. It doesn't necessarily equate to a similar assurance of crop yield. What it does mean is, for example, in this farm, everything that wasn't farmed is trees. So before anybody cut down a tree, they'd want to know, is there an opportunity here before they invested further? So this is probably the first step towards, do I even have the option of expanding my field? So it's almost a first step in a, you know, take the next step towards actually cutting down trees. Potential impacts on biodiversity and existing ecosystems were important to me in my mind, but I didn't get them into the study. For example, there have been studies about the trade-off between farming fields and trees. And as I said, this land is covered by trees. And so what is the detriment to the environment if I cut them down to make more farm fields? How do I balance that? And so that would also be another thing to evaluate in looking at the overall ecosystem before actually adding more fields. So again, this is the first step in a much larger complex system evaluation for whether or not it's even possible to expand to have more fields. I did share the results preliminarily with the farm owners, and they're very excited because one of them is interested in doing things like, gee, where could I, you know, have bees? Where could I look at alternate crops? You know, not just expanding for the traditional ones, but they're very excited to know that there are possibilities because they also are already acquiring permits they've acquired the permission to say these trees could be cut down for lumber, right? So they've already started to think about, what if I were to cut down these trees from a tree perspective, and also what would I put here in this place? So they're very excited to continue this exploration as well. Thank you so much. I really appreciate it. Any other questions?
Just in case, if you could put your email address there in the chat, in case anybody wants to follow up. But yeah, this is really interesting. It makes me hopeful because it seems like a lot of good could come from this if people kind of bought in and realized that they could contribute. I like it.
Thank you so much. Appreciate it.
And I know Brianna is working hard to get back on. She's trying one more thing. She should be good to join here in a second. And she's going to call in if her newer headset doesn't work. So we'll give her another minute or so here. I'm guessing Brianna feels frustrated because every time you join Brianna, I can see everybody has a little microphone except you. I'm not sure why, but oh, now I do. Oh, maybe not. Do I see it? Oh, yeah, I do now. So maybe it's working.
Can you hear me?
Yes, yay.
Okay, thank
Perfect
you.
timing. Yep, you can go ahead and share your screen whenever you're ready.
Okay, hold on a minute.
It's a little quiet, so if you can talk as closely to the mic as you can, that would be great.
Okay, let me know if you can't hear.
You should be able to share your screen and I'll let you know when we can see it. Looks like it's coming up. There we go. Great. So you can go ahead and get started when you're ready.
Okay. Okay, hello everyone. My name is Brianna, and before my presentation, I'd like to introduce myself. I became a master's in GIS student some years after I got a Bachelor of Arts in Geography. And during that time, I've worked as an assistant teacher and teacher in geography. But the main application of my GIS studies has actually been work that's more voluntary. I'm part of a cooperative, and one of my roles is to advise landowners on how best to manage their plots of land. And I also digitize maps of the land and maintain records and databases. And that partially formed my interest in land use management and the environment, which led to my interest in the topic of my capstone project, which is investigating land composition, urban compactness, and air pollution in French communes. Something else that sparked my interest in this topic is that several relatives and friends of mine have been experiencing side effects from exposure to pollution, specifically particulate pollution for the past few years, to the point of having to purchase humidifiers and use expectorants where they didn't have to do that before. It was such a drastic change, and there wasn't any noticeable change in pollution levels. So I wondered whether it was linked to some development that cleared a lot of vegetation nearby and replaced it with cultivated crops and hard surfaces. And not having localized data, I wanted to apply the research question to other places that did have sufficient data. Initially cities across Europe, but eventually settling for communes in France. And communes is the term for the smallest administrative division in France. So my overall intentions for this project, I wanted to find out whether landscape characteristics could help someone predict fine particulate levels in the atmosphere. And of course, the research studies say that, yes, you can, but I had specific characteristics in mind that I wanted to investigate, namely land use or land cover and urban compactness. So those are the two properties that I focused my project on. And something else I wanted was a comparison between places with good or close to ideal levels of fine particulates in the air and other places with excessive amounts of it. I was also concerned with longer term trends in this project, meaning annual average values over a 5-year period, as opposed to days or weeks. So before I delve into the project further, I want to give some background on fine particulate matter. PM 2.5 is another name for it, and that indicates that the particle sizes are 2.5 microns across or less. They end up in the atmosphere through both natural and human processes. And out of all the common air pollutants, PM 2.5 is said to be the worst. It's the most harmful to human health long term. It's linked to respiratory conditions and premature death. So it's very important to keep levels to a minimum. And the World Health Organization has set target levels, average annual target levels at 5 micrograms per cubic meter per year. Until recently, it was about 10 micrograms, but about 3 years ago, they concluded that the evidence showed that 5 was safer. For my project, I did end up using 10 as a dividing line between communes with high and low air quality, and I'll explain why I did that in a short while. There's been lots of research on land use patterns and fine particulate levels in the air, and those studies generally find that when you have more concrete, tarmac, and other artificial surfaces dominating the landscape, PM 2.5 levels are going to be higher. And on the flip side, vegetation, especially woodlands and natural grasslands, are closely linked to cleaner air. But the vegetation has to be well connected instead of fragmented across the landscape, or else you find higher pollution levels as if the vegetation wasn't there. Compactness has a more complex relationship with air quality. Some studies find that PM 2.5 levels are lower in compact cities, and others find that it's higher. But in general, the choice between high and low density development is a catch-22 of sorts, because compact spatial arrangements tend to expose more people to air pollution, and sprawled regions spread pollution over larger distances. So one scenario harms more people and the other scenario is worse for the environment. And neither of those are something that we would want. To calculate the values that represent land use cover, I used 2 landscape metrics, common in landscape ecology and urban landscape research. The first is landscape proportion, also known in some software as percentage of landscape. And that tells you what fraction of the landscape is covered by a particular land use type. The second is patch cohesion index, which tells you how aggregated or connected each land use type is across the landscape. For compactness, in practice, most calculations out there measure the reverse, which is urban sprawl or how spread out the spatial layout of a place is. There were a few calculations to choose from. I chose weighted urban proliferation calculation. It seemed to be a balanced metric. It considers percentage of built up area, degree of urban dispersion, and land utilization measurements combined into one value. And this slide shows the general steps involved and the data used. First of all, you need a land use raster that covers the whole of France, which I reclassified for this project. It was initially 23 land use classes. I simplified it to 7. Vector polygons for each commune. I used these to extract land use rasters for each commune only. And then software to perform the calculations. In this case, a landscape ecology statistics plugin from QGIS. And this slide shows the general steps for urban sprawl metrics, a binary raster of building footprints, which I created from polygon building footprints, vector polygons for the extent of each commune again, and then statistics on population size and jobs. I use the urban sprawl metric toolset, another plugin in QGIS to calculate the weighted urban proliferation value. And here I list the names of the communes I used for my study and the average PM 2.5 values over a 5-year period. I chose 5 communes for a group with good air quality, and 5 other communes to represent low air quality. And it was a stratified random sampling method. And as I mentioned before, I used below 10 micrograms, below and above 10 micrograms per cubic meter per year as a cutoff point between good and bad levels, even though the World Health Organization has changed their target recommendations. And I did it because very few places meet the new standards. The reason being is that when I looked at the monthly fine particulate level values for the French communes, the cleaner ones, the ones with a higher quality air, they often did meet those standards 11 months out of the year. But in many places, often there would be a spike in 1 month, usually February. There would be like a spike in PM 2.5 levels, and that one spike would skew the annual average to above 5 micrograms. So I consider that to be exceptional, but to be able to include as many places as possible, I used 10 or less as the target levels. Okay, and here the analysis results for the first calculation. So landscape proportion, I have a map showing a stacked bar charts for the relative values for land use type in each of the communes studied. It's superimposed on a map of interpolated PM 2.5 levels, the annual average for 5 years, and 2 graphs, one for urban landscape percentage, the other for vegetation landscape percentage. The results were more or less as I expected, or as previous studies would lead me to expect. Urban land use is correlated with higher average fine particulate levels, and vegetation land cover is negatively associated with it. These correlations are not perfect direct correlation, but you can easily see them based on the graphs. And the map, unlike the graphs, it includes agriculture as a land use type and shows generally the same pattern. You can spot individual places that are anomalies with like a larger percentage of urban land use type despite high air quality. But for the most part, you can predict some characteristics of land use type based on PM 2.5 levels. The second measurement, a patch cohesion index, which tells you how connected land use types are. I've represented the results using box plots here. On the left, you have higher air quality communes. On the right, lower air quality. But overall, the values didn't show much variation. For all land use types in both groups of communes, most values fell between 9 to 10. What differences existed were very slight, and you could technically say that the communes with higher air quality had vegetation cover that is more aggregated and connected, and that's true, but the differences were very minimal. So the third metric, weighted urban proliferation, also conformed to what was seen in several studies, where a more compact arrangement was linked to higher fine particulate levels, and that's shown in both the graph and on the map. As weighted urban proliferation values increase, that means the area is more sprawled. And the graph shows that particulate levels fall as that happens. The same thing with the map. Larger circles show greater sprawl. Smaller ones are more compact places. And you generally find more compact communes in more polluted areas, represented by the red, and more sprawl communes in less polluted areas, represented by the blue. So to summarize the findings, land use type metrics reflected a relationship with air pollution that was expected in terms of the extent of land cover. Connectedness of land use types, there wasn't much of a noticeable trend. And it seems that a compact spatial arrangement is linked to higher PM 2.5 levels, as seen in many previous studies. And so what's the difference with my project? Well, as I said in the beginning, it showed that these patterns are reflected when comparing places with high and low pollution levels. Places with good air quality status reflect the trends found for highly and moderately polluted cities, because those were the focus of all the research that I found so far. And the patterns apply to long-term PM 2.5 levels, not just weeks or months, like many studies tend to focus on. And it ultimately seems as if landscape is something urban planners should look into if they're concerned with particulate pollution and aiming to reduce those levels and the effects on, the population's health. But this was a preliminary study with quite a small sample size, and there are many things that could be done to expand it or extend it. The first most obvious one include a larger group of cities. Some type of regression analysis to put quantitative values to the relationships observed. The characteristics of the data didn't really allow much room for that type of analysis here, but perhaps with a larger sample size, it would be possible. Perhaps incorporating non-landscape factors that have been found to have an impact on air pollution, also population size and industrial presence, and comparing the spikes in particulate pollution at certain times of year for different types of communes. I was very interested when I saw that, it spiked at certain types of the year, but there wasn't enough time to investigate further. So that's it. That's my presentation. I hope it was easy to follow and sufficiently clear. And if there are any questions, I'll take them now.
Great job, Brianna. Anybody put some questions in the chat, please? There's a couple questions in the chat if you can see it.
Oh, I didn't. Okay, so you said I didn't realize that communes are the same as municipalities here. Will you share these findings with any communes? Oh, first of all, I really would like a larger sample size before I embark on, going to actual policymakers and trying to convince them to make changes based on this study. I'd like a more comprehensive sample size and be able to conduct more thorough correlation analysis, regression analysis, to have actual figures before I make my case about that to actual, policymakers and so on. Adrian says you touched upon this at the end, but can you reiterate how policymakers or planners might use this information? Well, urban development is something that's constantly ongoing, and there are continued decisions about where to place, new residential units, the types and of vegetation and how it should be arranged. Should it be, lawns or actual, should parks be comprised of like basically lawn type grasses or actual forested areas, actual forests that have been shown to be effective in removing pollution from the air. So I think there are many opportunities for land developers, those involved in urban planning, as urban areas are constantly expanding. There are just so many decisions that they make that affect, the landscape characteristics, that if they were shown, these results, then that could affect how they carry about, how they put together the spatial arrangement for all these urban development plans that they have, with urban sprawl and, you know building new infrastructure, road networks. So that was my idea for how policymakers might use the information, just incorporate it into their regular plans.
Okay, thanks for the answer to mine. That makes a lot of sense to have a larger sample size. Great job. If we don't have any other questions right now, Brianna, if you could put your email address in the chat just so people can grab it and they might want to follow up with another question. And thanks to everybody who presented today. Everybody did a really good job. Wednesday is our last day of presentations, with the final 7 presenters will start Wednesday at 12:30 p.m. Eastern again. So I hope we'll see you then. But nice job, everybody. I will make this recording available in the Capstone library as soon as it's done processing. Have a great rest of your day. Thanks.